please give a warm welcome to Managing Director at Fraction, MPC System Key Management, Bia O'Carroll.
Good morning, everyone. Thank you for coming on day 3, Monday morning. We really appreciate it. I am super psyched for our panel this morning, incredibly timely. First, I'd like to introduce my panelists. We've got our wonderful host, Tomas from RockawayX. We have our security sponsor, Luis from Halborn. And last but not least, Vitalis from Babylon Chain. So this is quite a crew for a security conversation. We've got market participant, security solutions provider, and a project. So I'm going to let the guys introduce themselves. Tell us a little bit about your companies, what you do, and what your role for your company is, please.
Hi, Tomas. I'm from RockawayX. I'm the events director. No, I'm joking. I'm just operating the validators and like all the infrastructure stuff. And what we do is basically we are running our own servers. It's like a bare metal, so we are not using any third parties or any cloud providers. So like nobody can touch my servers, and I think it's pretty important in terms of security.
Hello, guys. My name is Quispe Gonzales. I work for Halborn, a company specialized in cybersecurity for emerging technologies. We are talking about blockchain, smart contract, Web3 gaming, and all that stuff. I'm working as a senior security architect, and I have a lot of fun doing the cybersecurity part of the Web3 gaming.
Hi, everyone. I'm Vitalis. I'm the lead engineer at Babylon. And at Babylon, what we're doing is we're developing protocols to scale Bitcoin and share its security with Cosmos and the rest of the decentralized world.
Awesome. Thank you, guys. All right, so as I mentioned, this is a pretty timely panel. I'm sure you guys all saw on Twitter yesterday that Atomic Wallet is unfortunately having some issues. Looks like there's about 35 million worth of assets that have gone. Chainalysis put out a report this year saying that in total, about $3.8 billion worth of assets have been hacked. There was a Tornado Cash governance, malicious governance proposal that happened. There's a bunch of different ways we can kind of go on this panel, but I thought maybe we start at the 30,000 feet, Cosmos specifically. What does the security landscape look like for Cosmos? What's on your mind when you think about it?
Yeah, so Cosmos is great. That's why we're all here after all. But it enables chains to be sovereign, interoperable, and focus on their particular applications. But there are some security concerns to keep in mind. So these security concerns can be split into 2 categories, I would say. The first category is long range. So the main mechanism with which proof-of-stake chains ensure security is by being able to slash offenders of the protocol. However, when you go back in time, you lose security because the more back you go, the more possible is that the validators at this past state have already been unbounded. So if you discover something, a misbehavior back then, you might not be able to slash the offender. So to solve this issue, you need someone keeping track of what is the canonical chain. Cosmos right now does social consensus, which is a bit slow. At Babylon, we are using Bitcoin as the person that's always online and keeping track, which is the correct chain. And the other issue is short-range security. So when you think about short-range security, you think about the economic security of the chain in the sense that someone might accrue enough stake to take over the network. And if we want to have sovereign upchains and 1 million blockchains, then we need to be able to support both big and small blockchains. And small ones are more susceptible to those attacks. So what has been proposed lately, and it's all the rage right now, the hottest topic in Cosmos, is shared security. You have replicated security, where you have mesh security, and another protocol which the Babylon team has been researching, interchain timestamping. And all those protocols aim to enhance the security of smaller chains.
Great, thank you. Luis, how does Halborn fit into all of this?
Well, when we talk about security, we like to see everything in layers. So thinking about Cosmos, we can think a first layer, for example, validators. And each layer has their own challenges. Talking about validators, we can talk about, okay, how do we do the management of the key? That's something very important. If a key is lost or compromised, the validator game over. They have to worry about the distributed denial of service and obviously to protect the setup configuration of the validator. Going down, now we know that for Cosmos, we have a Tendermint core now that deals with all that networking and consensus part. So developers have to worry about the application part. So in this application, we can have different challenges. For example, what happens if the application produces a not deterministic behavior? It, as a consequence, produces that the consensus is not working very good. And as a consequence, it halts the blockchain. That's very dangerous. We can have different other kind of vulnerabilities, like, for example, integer overflow. Imagine we are dealing with an integer of 8 bits. It can support up to 255. If we zoom one more, it's going to be 0 again. If we don't deal this kind of logic, for example, any of decision can be taken in the application. Then we can go to another layer. For example, when they enable custom wasn't a smart contract, we can deal with different kind of vulnerabilities. For example, lack of authorization. We can deal with default values that are unexpected. Even when we just send tokens and the recipient is not well defined, it can produce some mistake. And one can wondering why the tokens is very basic, but custom wasn't has different ways to send tokens. Transfer function, send function, at the end, if you don't specify correctly or you don't validate who is sending the coins, you're going to, again, game over for the application. Then, if we go deeper, we have IBC. IBC has a very interesting model. The thing is, in comparison with other bridge technologies, but it doesn't make it exempt from vulnerabilities. In fact, the last year, in October approximately, was disclosed a bug that allows to basically take over a chain, exploiting the IBC commitment vector. And finally, we have the interchain. So I think we are going to discuss about this topic later, but it's basically, we're talking about replicated security, mesh security, and it's a hot topic right now.
Yeah, thank you.
Yeah.
Tomas, what do you make of all this? Because you guys are on the investing side, you're also on the validator side. Like, how do you evaluate these risks?
Yeah, basically, we are looking at the project from the early stages. So we are like going through the test nets, looking at the Discord, helping also like other validators to like get the network up and running and seeing like the issues that are happening. Because basically, we are like the base layer. Everything like the developers and the like, security auditors produce, we need to run it. So like we are the first ones who know like something is wrong. So yeah, that's it. And like in terms of like the whole security, I think a lot of people forget like it's an actual machine. It's not something like in the cloud, and like it's still like a machine, and somebody has to handle that and like get the keys right. So like you shouldn't have any keys on your server, and like the key for the consensus should be somewhere else. And also, as you mentioned, like the connectivity should be like pretty strong, so like nobody can take you down. And like I think like the security risk, like people don't think about it, but there is also like a risk of decentralization. So if one entity can like bring your chain down, it's basically the same as you mentioned, the consensus was stopped as a bug. So That's also like a big issue, and that's the reason why we are like not in the main data centers for all the crypto projects. So we have our own, which are basically like 5 milliseconds away.
You run your own data centers?
Yes, with
Yeah,
our own hardware.
With armed guards and everything?
Yeah,
the whole
yeah.
thing? Awesome.
Nobody can, like, nobody can touch my server.
Oh, that is very impressive. All right, so we touched a couple of times on the replicated versus mesh security, super hot topic in the Cosmos ecosystem right now. Could we like back up a little? Can someone just give me a definition of replicated security and mesh?
I can go ahead.
Great.
Is this on? Oh, yeah, it is. Yeah, so replicated security, I will try to be very short. I can talk about this all day, but yeah. So replicated security, the validator set of the provider chain is shared with the validator set of a consumer chain. So technically, the validators of the provider chain, for example, the Cosmos Hub, need to also run nodes for the consumer chain. And yeah, this is great. The main goal is to, for a consumer chain to get all of the economic security of the provider chain. And it also promotes the concept of hub minimalism in the sense that the provider chain can focus on just being a security provider, while the consumer chains can take charge of some of the more risky features or stuff that might open up gateways to vulnerabilities. But my main concern with it is that it has a lot of parallels with merge mining, which is actually the first form of shared security back in the proof-of-work days, because you give up some of your sovereignty, but in exchange for this security. And the main reason that the validators of the hub are validating for you is for profit. So once you stop being profitable, what happens? So in a general sense, I would say that replicated security is great, but for specific stuff. So for chains that provide some feature that the provider chain needs so that it can focus being a provider of security. But if I was building a chain that does not offer something to the hub other than some extra rewards, then I would think twice about doing it.
Cool.
Great. It's a very clear explanation. I would like to complement with the following. In mesh security, that we are thinking about the provider and the consumer. The provider, for example, Cosmos Hub, the consumer, for example, Juno. So the delegator of Cosmos Hub can delegate their atoms, the provider, their atoms, to the validators on Juno. That's a very cool feature. The thing is the following. Each one of those mechanisms, replicated security and mesh security, has their own pros and cons. So specifically for replicated security, where I see it's an issue in scalability. Why? Because all the set of validator of the provider are going to work for different consumers. So that's not so scalable over the time. It can produce many issues like, for example, inflation of atom price. So at the end, as Vitalis mentioned, it should be used under certain conditions. On the other hand, mesh security. The thing is, it was proposed to, for example, to cap the voting power, like for 10% approximately. So there is an interesting simulation for informal system regarding what would happen if you cap the voting power. So at the end, if you work with 10%, it's going to be better than not having shared security at all, but not so great. On the other hand, if you increase this value of voting power, what is going to happen that the security is going to be increased, even better than replicated security. But there is a bad part. If you allow that there is 100% of voting power, as a consequence, the provider can take over your entire chain. So it's important to understand what are the case uses for this kind of applications, and what is this magic number that allows to be secure, but not to be counterproductive for the sovereignty of every chain.
Fantastic. All right, let's.
Can I have one to that?
You
Because,
absolutely can, Tomas.
because like this is great, like the things working together, but there's like one thing which nobody like talk about, and it's the IBC, the relayers, because currently there's like no good incentive for the validators to run the relayer, and like without this technology, without this piece, it doesn't work. So like we need to work as an ecosystem on like making better incentives, and it's already in progress, so it will be better. But right now, it's like not a profitable business for a validator to run the relayer.
Yeah, I completely agree with Thomas. Like, relayers are the thing that is holding all of this together.
Yeah.
But yeah, currently, if a validator, if a relayer does not receive a grant, like they are running at a loss. Like, it's very important
Exactly.
to find mechanisms to help them, for them to get some rewards without having to look for grants. The new fee grant mechanism is a good step towards that, but we need much more towards that.
So could you tell us a little bit about that good step? Like what are the programs that are in place? That this is such a critical piece of the ecosystem. What do you guys think in terms of suggestions? What would be an ideal solution? Or could you describe the solution you just mentioned?
Yeah, the fee grant mechanism, I have watched it at a very high level, so it basically, relayers need to send transactions to both chains, and in order to send transactions, you need to pay gas. So the fee grant mechanism allows, the fee grant mechanism as well as an ICS, which I don't remember its name, allows for relayers to get refunded for the fees that they pay to send those transactions. So at least you do not only have losses in terms of fees, you only have operational costs right now.
Okay, but you're still basically a good citizen.
Yeah.
Because you're
It's public goods
okay.
to run it, because like for high availability, you need like multiple relayers to relay the same thing, but like the only one gets the fees. The first one which landed the transactions, the rest just pay the gas and like they get nothing.
Do you have any thoughts on like what do you think a good like next step to fix this is?
Definitely like maybe some kind of mechanism which will like the relayers will be like a round robin, so like everybody will get their part of like sending the transaction, and also like as Vitalis mentioned, like getting the fees back for
Very
the
cool.
gas.
All right, maybe at this conference next year we'll have a whole panel on that.
I hope so.
Excellent. All right, let's.
Can I make an open question about mesh security as well?
Sure.
Yeah, so a very central piece of mesh security is the price converter. So the cross-staked tokens from the provider chain need to be converted into local tokens in the consumer chain. And yeah, you need some kind of a price oracle in order to accomplish that. If you're a DEX, you can just look at historical data. But if you're not a DEX, you need to get this from someone else. So are there any other mechanisms to accomplish that? Like, does a chain need to rely on another chain to get the price conversion data? In order to ensure fairness, you can even do it badly.
Okay. Let's switch to governance, kind of a risk, a security issue that isn't always top of mind. I think it popped up last week or the week before with the Tornado Cash malicious proposal, and got some headlines. Is this something you guys worry about, Tomas? I mean, you guys obviously play a big role here. How do you think about it?
Like for customers, I see like the biggest issue currently is like those spammy proposals which have like links for users, like just click here and like you can claim something for voting, and I think it's a huge risk for you users especially.
How do you protect your team from that?
Internally we have like set the rule that like there's like a committee which like decides on what proposal we vote as validator. So like we are also like going through that and like checking if everything's okay, and also we are part of Validator Commons, so we are like engaging in the discussions about the proposals. So like because like if you're operating like 15 networks, there's like like every day is like 2 or 3 proposals you need to check, and like the ideas for validator commands is like offload like some small votings to the council there, and like they will give you the recommendation what to vote on.
For governance, it's very interesting because in security, we have a history of different attacks directly to the governance. Starting with, for example, voting power. What happens if an attacker is able to, for example, take a flash loan and to increase his voting power? As a consequence, he can vote a lot for a malicious proposal to be accepted, and in the end, he executes it. That's something that has happened in different projects. Another issue regarding security is lack of understanding of the technical proposal. What happened with Tornado Cash? People vote for yes without understanding what was the real consequence of accepting that proposal. So it's very challenging to try to deal with this kind of situation. Then we have, obviously, the incorrect implementation of the governance logic itself. What happens? We have seen many cases where, because of the logic, the voting power is increased because it counts twice a vote. Or, for example, the weight of the votes are not calculated correctly. So, as a consequence, someone can realize about that issue and can start trying to take advantage of that.
And this is actually a very timely question because due to the recent updates to the Gov module, I don't think it's deployed in the hub, but a new good feature that might enable attacks, though, such as the Tornado Cache, is that the Gov module now can actually execute arbitrary messages. It's not just 4 different types of proposals. Now you can execute arbitrary messages. So, yeah, like, be careful what you accept.
Yeah, and a good security measure, even for the execution of arbitrary commands, etc., it's to have a time lock. Because at the end, if you have a time lock, it means that if your proposal gets accepted, you have to wait some time, let's say 48 hours, for example, before executing the proposal. In that time, if you realize that the proposal is a malicious one, you can take different actions, like, for example, stopping a contract or draining the funds or whatever, or do a migration, whatever. But at least give you some time to think about how to deal with this situation.
All right, excellent. All right, let's go to sort of DeFi risk and smart contract risk and key management, right? So I work for a company called Fraction. We're an MPC, key management system. How do you think about this besides your very protected data centers? Like, what are the policies? What wakes you up at 2 o'clock in the morning in a cold sweat? Like, oh my God, did we do this?
Like, what wakes me up is our like monitoring system that wakes me up in 2 in the morning. But like, the biggest risk we are facing is someone basically like attacking the operating system and like finding bugs in like Tendermint or Cosmos SDK, because like we have pretty strict rules for the keys. So like there should be like if the chain or the technology allows, there is like a no key on the server. So like even like somebody can hack into our server, like nothing will happen because like the keys are stored somewhere else, and you cannot like get it from there because like we are using like a hardware signer HSM with TMKMS, so like it's on a separate machine, and you cannot you also like the way it's done, you cannot connect from the validator to the TMKMS like on the network level. So like, and like all the servers we have like are isolated, so like if you hack the server, you have no idea of the rest of the network because like you cannot communicate with the rest. And yeah, also like for the bridges hack, because we are operating few chains which also are using like bridges with Ethereum and so on. For us, it's critical to be part of the community, and if there's something happening, we need to react fast.
Got it. Now, Halborn, Luis, I come from a trading and markets background, and in one of my previous roles, worked really closely with your awesome team. And I know when I was in like Tomas's position from a trading and markets background, I wanted to talk to Halborn because I don't know how to interpret a smart contract audit, right? I don't know how am I supposed to think about it? So I know you guys have advisory service as well as audits for the actual projects themselves. How does that work? How do we think about it?
Very interesting question. The thing is, when we think about security in Web3 space, we think a lot about smart contracts. But it's not the only component we need to worry about. Actually, smart contract is part of all the ecosystem. So one way to see the security is like a process end-to-end. So you have a front end, you have a back end, you have wallet, you have validator, you have smart contracts. So it's ideally, you have to take security measures in each one of those components. Being said that, when we deal with a project, we try to understand what are all those components that are part of this solution, and try to do what it's called a threat modeling. What does it mean? That we try to see what an attacker could do in each one of those components and try to model an attack and try to reproduce that. So for example, if we see that a smart contract has certain entry points, we try to think like an attacker. What an attacker would do in this kind of situation? Or what are the circumstances that allow an attacker to take advantage or exploit this contract? So in a formal process, we understand the components, we did a threat modeling, and after that, giving a certain scope, we try different techniques. Obviously, reading the code base is very important. I have to highlight this. If you understand the code and all the logic behind that, it's easier for you as a hacker to understand how to attack it. So very important to understand DeFi protocol, for example, understand what is the logic behind. After that, obviously, if the technology allows you to use some tools to discover, let's see, low-hanging fruits, but in my experience, I have to say that the issues that has more impact are the issues discovered manually. So it depends a lot of the experience of the hacker to try to discover vulnerabilities in different components of a solution.
How can a team help you do a better security audit?
Actually, what is very important is to have a very deep knowledge in certain technology. For example, if we are talking about Cosmos, well, there are people that specialize in Cosmos ecosystem. If we talk about EVM, the same. Solana, the same. So ideally, it's to have a security provider that has this experience in each one of those technologies, because at the end, the vulnerabilities in EVM, for example, reentrancy, is not going to be applied to Cosmos wasn't. Doesn't make sense. So you have to have a different framework, a different set of tools, a different, top vulnerabilities to test against the component.
All right, we're coming close to the end of the session. Since we've got 3 security experts here, if you could give the audience a pro tip, like if you don't do anything else, make sure you know all about this, or if you don't do anything else, make sure you have a giant guy with a big gun outside of your data center. Like, what would be your advice to the Cosmos ecosystem?
Definitely get a ledger or some other device. Like, do not store it in your wallet, like Atomic wallet or like Kepler. Use a hardware wallet, definitely.
Well, the pro tip is the following. Guys, use the common sense that, sadly, is the less common of all the sense. Sadly, what happens if you see the attacks? You discover that those attacks, some of them are technical, very technical, but most of them are because someone clicked a link from an unknown email. Or, for example, he said in a Discord that someone wrote about an opportunity and he tried to take advantage of that opportunity. So nothing is free in this life, and it's very true for security as well. So, for example, protecting, as Tomas mentioned, protecting your keys in a separate space, because if someone compromises your computer, your server, your keys that protect your assets are lost. And you can now go to customer service asking for your assets.
Yeah.
Yep, I would give a more theoretical one, like know the systems that your code runs on, at a high level know how Tendermint works, know the security properties on a high level, and like look for solutions that can help you secure your chains more.
Excellent, thank you. Any questions?
I have one. We want to know what fraction MPCH does.
So fraction is an
This moderating skill, you must have some special perspective.
so security obviously really paramount for us. We have a combination system, you'll be happy to hear. So we have HSMs and we use MPC security as well. Thank you for asking, Sam. And we support the Cosmos ecosystem. The founders of Fraction were original validators, cosmonauts going way back, so that we were very excited to get this opportunity to sponsor the conference. So thank you very much for having us. And happy to work with any of the projects that are looking for more like, I hate this word institutional, but the institutional solution that when you need governance policies. All right, awesome. So stay safe. We're all floating around. If you have any questions for any of us, hit us up. Thank you very much, panelists.
Thank you so much. Thank you.